Welcome back. Now we start problems on Stat 5.3. Problem 1. Find each probability by referring to the tree diagram above. Okay. Enlarge it so we can see what's going on. So that's A and B. So that's your start. Event A occurs, which is for probability 0.1. Event B occurs with a probability of 0.9. After A, C and D. After B, C and D with their respective probabilities. What is the probability of C given A? So A is given, then what is the probability of C occurring? That is 0.25. All right. Next. What is the probability of D given B? Given B, what is the probability of D? 0.45. C, what is the probability of A and C? Of A and C. So this entire branch is 0.1 times 0.25. 0.1 star 0.25. Probability of B and D. B and D. 0.9 times 0.45. Probability of C. Well, C can happen here or here. So this branch, this entire sequence, or this entire sequence. All right. So that is 0.1 times 0.25 plus 0.9 times 0.55. That was this one. Probability of D is this sequence or this sequence. So 0.1 times 0.75 plus 0.9 times 0.45. All right. Next problem. Jana has 5 pairs of shoes, 8 skirts, 3 hats, and 10 blouses. How many distinct outfits does she have? Well, this is one of those. What is an outfit? An outfit consists of some number of shoes, skirts, hats, and blouses. All right. How many pairs of shoes does she have? 5. Times skirts 8 times hats 3 times 10 for the blouses. So you need to multiply all these numbers. All right. So that gives us 5 times 8 times 3 times 10. Next problem. Count the number of ways to arrange a sample of 5 elements from a population of 12. Well, you want to choose 5 from 12. It's a sample. In other words, it's a group, right? So what we are going to do is use a combination. So let's get our calculator ready. in this calculator, you're looking for combinations. So let's say in the functions, you're looking at combinations. Why did I choose combinations? Because order is not important. So from 12, I want to choose 5. So the answer is 792. Okay, 792. So these are various ways of finding 5-element samples from 12 elements. So if random sampling is to be employed, the probability that any particular, so one sample is chosen out of these guys. So it is 1 over 792. Next. In how many ways can 3 different novels, 4 different mathematics books, and 1 biology book be arranged? Okay. You want to arrange them in order, and any order is okay. All right. So first, the books can be arranged in any order. So let's make a drawing. How many books do I have? 3 plus 4, 7 plus 1, 8 books in all. Okay. So when I have 8 books in all, all right. So for a part, I'm going to say, well, I'm going to arrange them, right? So you have all the books to be arranged. So there are 8 books. You want to arrange them all. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 books. First book you could have 8 options. Second book you have 7 options. Third book you have 6 options because you have made this choice. One book is chosen. Second book is chosen. Third book is chosen. So you have 5 books left. Well, after 4 books, 4 books left. After having chosen 5 slots, you have 3 books left, 2 books, and finally 1 book. So this is a factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 factorial. So we have our calculator, right? So numbers 8 function factorial. 40,320 different ways. All right. The mathematics books must be together and the novels must be together. So now this is a different problem. So what is this a problem? How is it different? Now these 8 books, there are the 3 novels. That would be one block, novels, right? Mathematics, they would be another block. And then biology by itself could be one block, one small block. Okay? Within each, you have some rearrangement. All right? Order is important, but within each, so there are 3 novels. They can be arranged in 3 factorial ways. Now, mathematics. There are 4 books, so they can be arranged in 4 factorial ways. Biology is 1 book, so it's 1 factorial ways. Okay, 1 factorial is simply 1. Moreover, NMB, they can be arranged in order. What does that mean? I can have M first, N next, B, m first, b next, n, or n first, m next, b, or n first, b next, m, or b first, m next, n, or b first, n next, and then m. So there are 6 ways of arranging this particular number. 3 factorial times 4 factorial times 1. So what does that mean? So I'm going to have first 3 factorial, 4 factorial times 1, 3 factorial times 4 factorial times 1 factorial. So that's this arrangement. And then 6 times these guys. So times 6. 6 because I could have these blocks moved about. Okay. So that gets me 864. All right. The mathematics books must be together, but the other books can be arranged in any order. So what does that mean? Now you have mathematics as one block. Okay. So you have the 4 mathematics as one block, which gets me 4 factorial. And then the other blocks, other books. Okay. The other books can be arranged in any order. So it is not exactly a block. I mean, they don't have to be together. So I cannot think of that. But I need to think of this as one block. Well, the others are 3 books and 1 book in all, novels and biology put together, 4 books. So I can think of this as one block, one book, and then there are 4 others books. So that gets me in all 5 books. That's 5 factorial. And then the mathematics books can be rearranged. 5 factorial times 4 factorial. All right. Five factorial times 4 factorial. 2880. Let's see. Okay. Next problems I'll start on the next video.